Welcome to another edition of Mathematics Meal. This is an important program that is very helpful to students as far as mathematics is concerned. You cannot afford to miss this program. So make sure that you participate in this program and also invite your friends to take part in this program. It will go a long way in helping them in the subject mathematics. So far we have been looking at theory of logarithm, and we have looked at the meaning. We have also looked at the laws. We have looked at some parts of simplification, and we are now on the last part, which is the third case of simplification of terms and expressions involving logarithm. Now, these questions can also be modified, but no matter the modification, they will just revolve around these three cases that we have looked at. That's the case when we have one log operator, when we have many log operator, and now case 3 when we have division of what? Of logarithm. So when we have division of logarithm like this log 8 divided by log 32, what do we do? What do we do? How do we simplify expressions or terms like this? We have about 5 steps that we need to take. Then there are other important notes that we need to consider as we solve this problem. So we're going to apply these steps in solving this particular problem on division, and we apply it also in solving subsequent problems on what? On division of logarithm. Remember, division of logarithm is not the same thing as what the second law is telling us. When we have this is not division of logarithm, but division of the numbers in logarithm. That's what the second law is saying. In this case now, we do not have log m divided by log n. No, it is now a common log. But here we have log 8 divided by log 32. So we are dividing. So this log 8 divided by log 32. It's not the same thing with this, but rather it is this. Sorry, it is this. This is this. So it's not the same thing as this one, no? It's not the same thing. So we have a different way of handling division of logarithm. So we have 5 steps that we are going to apply. Now quickly we are going to apply these steps. When we have division of logarithm, what do we do? What are we expected to do? Like you used to do in other problems. Take note of the expression. Take note of the expression. Take note of the expression. So look at the expression, we have to take note of it. Take note of the expression. And if we take note of the expression here, we have log 4 over log 32. We have taken note of it. They say reduce the numerator and the denominator to a single log if they do not contain single log, using appropriate log or logs. This is a single log, this is a single log. So if this does not contain a single log, we reduce it to a single log. Likewise, like here, we apply this second step here now if we want to solve this problem now, because we don't have single log here. What we have here is we have 2 logs. So we need to apply the appropriate log to reduce it first to a single log. But in this problem now, we are going to skip step what? Step 2. Because that's why we have the if statement. If, in this case now, we have just single log, so we don't need to reduce anything because they are already single log and single log. Okay, we move to step 3. Write the numbers in index form using the same ancestor where necessary. Okay, 4 and 32, they have the same ancestor, which is 2. So we have to write them in index form using the same ancestor. If I write 4 in terms of the ancestor 2, it will be 2 raised to power 2. If I write 32 in terms of the ancestor 2, it will be 2 raised to power of 5. Having done that, when you go back again, then use appropriate laws to remove the powers. So we need to remove the power. Remember the third law, this power is something as the coefficient. We have this. And this power is also the coefficient. We have that. Okay? They say now, since the log are now the same, look at it, the logarithm are the same, logarithm of 2, logarithm of 2. They say divide them and simplify the remaining expression. So these two are the same, so they can divide. Log 2 can divide log 2. I'm left with 2 over what? 5. So log 4 all upon log 32 will give us 2 over 5. Somebody is about saying something. I noticed that maybe you did not notice it. We did not have bases here, and that's why we have to take note of this. In most cases of division of logarithm, the base is not usually what indicated. I think that solves that problem. This implies that the bases are what? The same. Once they are not indicated, it means the bases are the same. You can insert any base there. They are the same. That's what it means. But the reference base in logarithm is usually logarithm in base 10. That's the reference base. So that's why I have to make this statement before someone will begin to say, where is the base? Now we just have only the numbers. Here, no base. Here, no base. That's why in division, we don't usually indicate the bases. And then I say the second, made the second statement. Two logarithms can be divided if they have the same word base. So if I have maybe log 8 base 2 over log 8 base 3, you cannot divide them. You can't cancel out it because the bases are not what? The same. They're not. So here, no base, meaning their base is no base. The base of this one is no base. So you see they have the same base. So once they have the same base, that's when it's possible for you to actually divide them. So we say, in a case, thus, if the bases are not the same, we simplify them separately, like we did in case 2. So it means you handle this separately, and reduce them separately. Okay, we're going to go on a short break. And when we return, we're going to continue with more problems on division of logarithm, which is the third and final case on simplification of terms and expressions involving logarithm. Don't go anywhere. Stay tuned because Mathematics Meal is going to be back just in a short while. Thank you.